All right, let's just jump right in with a wild question. What would happen if you fell into Jupiter? Here on The Explainer, we're about to take a scientifically grounded journey deep into the heart of our solar system's biggest and maybe most mysterious planet.
I mean, it's a question that sounds like pure science fiction, right? But here's the cool part. We can actually answer it. Thanks to some incredible data from NASA's Juno mission and the very latest research, we can piece together what this, well, terrifying voyage would really be like.
Okay, so picture this. Your journey doesn't start with a landing because, well, there's nothing to land on. Instead, it begins with an unimaginably fast plunge right from the very top of the planet's swirling atmosphere.
And when I say fast, I mean fast. We're talking 180,000 kilometers per hour. To give you some perspective, that's way faster than any spacecraft orbiting Earth. And it's all because of Jupiter's absolutely colossal gravitational pull. So after just a few minutes of falling, you'd slam into the first visible cloud deck. You could still see the sun, sure, but it's just this distant pinpoint of light. Its warmth would be a completely forgotten memory as you plunge into these freezing, wispy clouds made of ammonia ice crystals. But here's the thing. You're not just falling straight down. Not even close. You're being violently thrown around by the most extreme, the most chaotic weather in the entire solar system. Seriously.
You see, Jupiter is the fastest spinning planet out there. It does a full rotation in under 10 hours. And that incredible speed whips its atmosphere into these ferocious jet streams and creates colossal, centuries-old hurricanes. We're talking about things like the famous Great Red Spot, a storm so huge it could literally swallow our entire planet whole.
And for centuries, we could only see the surface of the Great Red Spot. But check this out. Recent gravity data from the Juno probe has let us measure its depth for the very first time, and it is staggering. It plunges 500 kilometers down into the atmosphere. To put that into perspective, if a storm that deep started here on Earth, it would stretch all the way up to the International Space Station. I mean, it's unimaginable here. But on Jupiter, it's just Tuesday.
Okay, let's talk about the clouds themselves because this is where our journey takes a really fascinating scientific plot twist. It's one that has completely upended everything we thought we knew.
For decades, the story was really simple. You'd read it in every textbook. The beautiful, colorful bands of Jupiter, oh, those are just layers of ammonia ice clouds. Simple, easy. Except, it turns out the story isn't that simple at all. You see brand new findings, and this is cool, pioneered by a team-up between professional and amateur astronomers. They found a huge problem with that old theory. The main cloud deck is actually way down in a layer that's too warm for ammonia ice to even form. This one discovery completely changes how we look at every single picture of Jupiter. So what does that mean? Well, it means the incredible colors we see probably aren't from pure ammonia at all. The leading theory now is that they're caused by clouds of something called ammonium hydrosulphide, which then mixes with a kind of sun-induced smog, basically. And that's what paints the planet with its famous reds, oranges, and browns. Okay, so as we keep falling, we leave those sunlit layers far, far behind. And now the environment just becomes more and more alien, more hostile, and just crushingly immense. At this point, you've been falling for about 12 hours. You've just blown past the deepest point humanity has ever reached with a probe. That was the Galileo probe, back in 1995, and it was completely obliterated by the pressure right here. You are now in total pitch-black darkness. It's so deep that not even radio waves can escape. You are utterly and completely alone. But it's not entirely dark. The abyss is suddenly lit up by these insane flashes of lightning. And these are not like the storms we have on Earth, which happen up in water clouds near the surface. No, these are monstrous flashes coming from deep, deep within the planet. And the sheer power is just staggering. We're talking about lightning bolts that are 100 times brighter than the most powerful strikes on Earth. They just tear through the darkness, briefly lighting up this chaotic, churning world of pressurized gas. All right, we're now entering the final stage of this insane journey. This is where the pressure and the temperature get so extreme that the very laws of physics start to warp into these bizarre, exotic forms. And this next part, I find this absolutely mind-blowing. The hydrogen gas that's been all around you this entire time, it starts to transform. Under the immense pressure, it first becomes this weird thing called a supercritical fluid.
It's not a liquid, it's not a gas, it's something in between. And as you go even deeper, it gets crushed into a flowing liquid metallic hydrogen. This stuff is so strange, we've only just recently been able to create it for tiny fractions of a second in labs here on Earth. The pressure is just building and building to an absolutely incomprehensible level, 2 million times greater than the atmospheric pressure you feel at sea level on Earth. How do you even wrap your head around that kind of force? Try to imagine the weight of not one, but two Empire State Buildings, balanced perfectly on something the size of your thumbnail. That is the kind of force we're talking about. It's what crushes atoms into totally new exotic states of matter. And hey, if the pressure somehow doesn't get you, the heat definitely will. The temperature near Jupiter's core is estimated to be around 20,000 degrees Celsius. Let me say that again, 20,000 degrees. That's 3 times hotter than the surface of the sun itself. So look, it's obvious no one could ever survive this journey. But here's the beautiful paradox. Jupiter's terrifying, hostile nature is actually a huge blessing for us. Its massive gravity has been our cosmic bodyguard for billions of years, deflecting countless asteroids and comets that could have slammed into Earth. You could even argue it's one of the key reasons life was able to flourish here in the first place. So this whole journey just proves that Jupiter is profoundly inhospitable. It's a dead end for life as we know it. But it leaves us with one last tantalizing question. The gas giant itself might be a killer, but what about its moons? Could its ocean moon, Europa, with that vast hidden ocean under the ice, could that be our best chance of finding life beyond Earth? All of it, thriving right there, thanks to the protection of the very same terrifying giant it orbits?